Of our previous discussion in Cauchy's residue theorem. So we are using the concept in Z-transform. So what we have discussed is how to find residue. That is where we stopped in the previous discussion. So now we are going to solve and we are going to find the residues for each Z value, for each Z. That is here Z is equal to 1 and Z equal to 2. So as I told you, this is the concept what we are going to use here. Listen carefully. So this part is what it is in the right hand side. So here what is Z equal to 1. So let us assume it is similar to Z equal to 8, because this can be rewritten as residue at Z equal to A x of Z into Z power n minus 1, which is equal to this. Let us assume this as a formula. So we are going to apply this formula. Okay. So you see here, limit Z tends to A. What is A? A is 1 here. A is 1 here. So Z tends to 1. Then what is Z minus A? So A is 1 here. So I am writing Z minus 1. So what is this? X of Z into Z power n minus 1. That is what is here. So 10Z by Z minus 1 into Z minus 2 into Z power n, Z power minus 1. Can I write like this? Can I write like this? Z power n, Z power minus 1. What is here? Z power 1. Am I right? If you combine all these three Z's together, what do you get?
Z power.
So Z power 1, Z power minus 1, they cancel each other. You will get Z power n. That is what is here. Z power n. Okay. This is the next step of this. When you bring this inside, so you will get this step again. When you combine the Z's together, you will get this result. Got it? Now, this is Z power n, Z power n, n, Z power n. Okay. Now, listen. So after this, you can cancel these two terms. Am I right? You can cancel these two terms. This is the remaining part. Now you can apply this Z equal Z implies 1 here. So when 1 comes here, wherever you have Z, you have to apply. That is the concept of limits. So if I apply Z equal to 1, so 1 power n, 1 minus 2. 1 minus 2 is minus 1. So you get. So this is the result what you get. This is the result what you get. So 10 into 1 power n by minus 1. So 1 power anything is again it is 1. Am I right? So 1 power n is again 1. So here denominator is minus 1. So it is minus 10. So this is your first residue. This is the first residue for your simple pole Z equal to 1. So you have to find the residues for the number of Z terms you have. Suppose if you have another term Z equal to 3, Z equal to 4, you have to find 4 residues here. Okay, according to the number of poles there. Okay, now the same concept you are going to use for Z equal to 2. Okay, so same process. You can understand. This is the formula you are going to apply. Here Z equal to 2. Am I right? When Z equal to 2 here, when Z is equal to 2 here, then here Z tends to 2. So that is what is here. Limit Z tends to 2. Z minus A. A is 2 here. So Z minus 2. And this is your function there. So you are applying the function. You can cancel Z minus 2 on the numerator denominator. So that you will get this result. The balance terms here. Now you apply wherever you have Z as 2. So you have 10 into 2 power n. So after cancelling you get this step. Then when you subtract Z equal to 2 here, you get 10 into 2 power n by 2 minus 1 is 1. Am I right? So this is 10 into 2 power n. So this is the residue when Z equal to 2. Now you have 2 residues since you had 2 poles here. So after finding all these residues, you have to substitute in the formula. What is the formula here? What is the expansion here? 2 pi I into sum of residues. Sum of residues of this term. So that is what is here. So what I am doing, I am adding all the residues. So you have to see x of n. X of n is nothing but the sum of residues. So I am adding the concept, that is residue at Z equal to 1 plus residue at Z equal to 2. Am I right? I am adding these two. That is what is it here. Sum of residues. So the first term is, so here it is 10 2 power n. The other residue is minus 10. I am just writing both together. So 10 2 power n minus 10. So we can take 10 as common outside. So you get this result. After finding this, you can come there. So our question is Z power 1 10Z by Z minus 1 into Z minus 2 which can be written as 2 pi I into sum of residues. Sum of residues is nothing but 10 into 2 power n minus 1 as the answer. So this is how you use Cauchy's residue method to find the Z inverse concept. Okay.